to the continuation of the topic set. We are still on operations in set. So we want to see inverse of a relation and composition of a relation. Relation simply means set of ordered pairs. You can see in the question above here, this is a typical example of set of ordered pairs because the elements are in twos. The elements are in twos. So they are said to be a relation because they are set of ordered pairs. Then, what do we mean by inverse of a relation? Take for instance, inverse of a relation means B inverse. Look at this B now, set B. Now, the first element there is called the first coordinate, that is the domain. While the second element is called the second coordinate, that is the range. First coordinate domain, second coordinate range. First coordinate domain, second coordinate range, etc. Now, what they mean by B inverse or inverse of a relation means interchange these elements you are seeing here. Here, if you carry the second coordinate, put it in the first, carry the first, put it in the second, it will be giving you E, comma, E. This one will come first, this one will come second, it will be giving you 2, comma, G. This one first, this one second, 3, comma, G. This one first, this one second, D, comma, C. This one first, this one second, C, comma, C. This is inverse of B. Okay, now we want to see, we have seen how to get inverse of any given relation. We want to see how to get composition of a relation. I repeat, composition of a relation. How do you get it? Composition of a relation is denoted by A composition B. It means you are getting composition of A and B. Now, what do you do? How do you get it? This is the first coordinate, second coordinate, that is the domain, that is the range, domain, range, etc. This is domain A, and this is range A. The first element, domain A, the second element, range A. First element, domain A, second element, range A. Now, how do you get the composition of this relation? See what you do. Check where the first coordinates and the second coordinates of that second set, where they are equal. I repeat, check out where the first coordinates and the second coordinates of the second set are equal. Once you get it, write down, once you get where they are equal, write down domain B, comma, range A. See what we mean. See how you check it. The first element A, or the first coordinate A, is it equal to the second? No. Is it equal to the second? No. Is it equal to the second 3? No. Is it equal to the second D? No. Is it equal to the second C? No. You go to the second first coordinates. A, is it equal to E? No. Is it equal to 2? No. Is it equal to 3? No. Is it equal to D? No. Is it equal to C? No. Still A, is it equal to E? No. Is it equal to 2? No. Is it equal to 3? No. Is it equal to 4? No. Is it equal to D? No. Is it equal to C? No. That is the first coordinates and the second coordinates of the second set. Now you go to the first coordinate of this one, which is B. B, are you equal to E? No. Is it equal to 2? No. Is it equal to 3? No. Is it equal to D? No. Is it equal to C? No. You go to E. E, are you equal to the second one? E, is it equal to E? Yes. Since this E is equal to this E, that is the first coordinate here is equal to the second coordinate here, you just say, I've gotten the answer. Now, here is called domain domain B. Y here is called range A. So you write the domain B first. That is what I mean by domain B, range A. Write domain B first. What is our domain B? You say domain B is A. What is our range A? You say it is 2. So this is the answer for the composition of A, set A and set B. Okay? So watch the next video as we go into interpretation of set, interpretation of Venn diagrams. Don't forget to subscribe to our YouTube channel, like our video as you enjoy. Keep in touch with our video to see interpretation of Venn diagram. See